Okay, so we're gonna talk about exponents today. Exponents, evaluating expressions with exponents. Let's say we have 2 to the third. This would equal 3 factors of 2 multiplied together. So we're gonna have 2 times 2, which is 4, times another 2, which is 8. So this is gonna equal 8. There are some things you gotta look out for, like the difference between negative 2 to the third and a negative 2 to the third this way. Well, here this reads a negative 2 times a negative 2 times a negative 2. And this one here reads a negative 1. Let's even write this here without it. So we're going to have a negative 1 times 2 times 2 times 2. So for seeing a negative outside of parentheses, we need to think of this as being negative 1 times 2 to the third. Okay, so what's the difference between negative 2 squared and a negative 2 squared? Well, like I said, this is going to end up being a positive 4 for the reasoning of a negative 2 times a negative 2 is going to give us a negative times negative, so we get the positive 4. Whereas this one is going to have a negative 1 times a negative 2 times a positive 2 times a positive 2, which gives you a negative 4. Things like 2 times 3 squared. This is not going to be 6 squared for the reasons of PEMDAS, or the order of operations we learned earlier. We have to make sure we square the 3 first, so this becomes a 9 times a 2, which is going to give us an 18. See, these are just examples of evaluating expressions with exponents. We also have several rules for these things, one of which being the product rule for exponents, saying that if you have the same base that you're multiplying, you're going to add these exponents. So this would equal a to the m plus n. And we do this since if we have a 2 to the third times a 2 squared, this would equal a 2 to the 3 plus 2. Because 2 to the third would end up being 2 times 2 times 2, and 2 squared would be another 2 times 2. If we multiply all these things together, we have 5 factors of 2, which would give us a 2 to the 5th, just like this gives us a 2 to the 5th. The same applies really for the quotient rule for exponents. Almost the same property here, except now we're going to say it's a to the m divided by a to the n. And this is going to equal a to the m minus n, since if we have a 2 to the third over, let's say, a 2 squared, this would equal 2 times 2 times 2 over 2 times 2. And using rules from earlier, we can start canceling out factors. And when you cancel out factors, they turn into 1s. So you end up having a 2 over 1. Or we could have looked at this using our rule, saying this could have been 2 to the 3 minus 2, which equals 2 to the 1 power, or in other words, 2. This is an example of the quotient rule for exponents. We also have the 0 exponent, which is really weird that we think of the number 3 to the 0. This is going to equal 1. A to the 0, this is going to equal 1. Anything to the 0 is going to equal 1. And I like to look at this as being, well, okay, let's say if we have 2 cubed, or 2 to the third power, over 2 to the third power, this would give us a 2 times 2 times 2 over 2 times 2 times 2. Things would start canceling out, turning into 1s, and what happens when you're done, you end up having a 1 over 1. Or something over itself we know is 1. That's another way to think of this thing. So if you were looking at using this rule of the quotient rule, you're going to have a 2 to the third minus 3, which equals 2 to the 0. But for same reason, this is going to be 1, this is going to equal 1, and this is why we have this 0 rule for exponents. The last rule we're going to talk about is the power of a product or a quotient. Talk about both of those in one because they kind of use the same properties as well. And this rule says if we have some a times b raised to the n, this is going to equal a to the n times a b to the n. And we do this since if we have, let's say, the number 6 squared. This can equal, well, we know it's 36. I like to look at this as 2 times 3. Now this is a product like AB, and we're going to raise this to the second power. Well, this can also be looked at as being 2 squared times 3 squared using our rule. What this would become now is going to be a 2 times 2 times 3 times 3, which still is going to equal our 36. Doing the same stuff with the quotient, all we're going to have now is a over b raised to the n. Now this rule says we're going to have a to the n over b to the n. And an example by looking at this, we can say, well, if we have 2 over 3 raised to the third power, well, just like anything raised to an exponent, this means 2 over 3 times 2 over 3 times a 2 over 3. Multiplying straight across, we would have 2 raised to the third over 3 raised to the third, which illustrates our property right here. Oh yeah, things I didn't mention was we can only do this if b is not 0. If b is 0, this property doesn't work because then we have an undefined situation. So these properties are only going to work if you don't have an undefined expression. So let's make sure that b is not 0 in a case like this. Okay, so lastly we have the rule of the power rule for exponents. And this is where you're going to have an a to the m raised to the n. And they say this is equal to a m times n. And we do this because if we have, let's say we have the number 3 squared and then to the third power, where this can equal 3 squared. So something raised to the third power is something times itself times itself. So we have 3 factors of what we got going on. Now if we were to multiply these things out using the first rule we learned about, our product rule for exponents, we would have to take these things and add them. So this could be looked at as being 3 to the 2 plus 2 plus 2, which could be a 3 to the 6th. If we were to take our rule here and say we have 3 to squared raised to the third, using our rule, we would multiply the 3 times the 2. This would give us 3 to the 6th. Let's see. Also, when you're doing this, make sure you know that 3x, these things are not attached. So if I have 3x squared raised to the third, this is not going to equal 3x to the 6th using this rule. And this is because we actually have a product here. This product has this 3 and an x squared. Now these things are being multiplied together, so this 3 would have to apply to both of these, just like using the product rule. So in order to get our answer, so going from 3 squared, so going from 3x squared raised to the third, this would have to give us a 3 to the third x to the 6th. Since we would have to look at this as being 3 times x squared times 3 times x squared and a 3 times x squared. Since I have this factor raised to the third, I have 3 factors of those. Now looking at this thing, this is like having a 3 times, I'm going to group things next to each other. So we have a 3 times 3 times 3 and an x squared times x squared times x squared. Whereas this part here would give us a 3 to the third. This other part here would give us x to the 6th, since there's 6 of those, giving us 3 to the third x to the 6th, or 3 to the third is 3 times 3 times 3, which is going to give us a 27 x to the 6th. Rather than thinking of this earlier as having a 3x to the 6th, where this is not right. So I think a very important part of this section is do not think that 3x is all attached and you're only going to apply this to this one exponent. We need to make sure, remember, these things are factors. They have their own exponents. And using this power rule, we must multiply the exponents for every factor.